Okay guys, today our lesson is to be able to identify and graph linear functions. A linear function is a function whose graph is a non-vertical line. A linear function can be written in the form y is equal to mx plus b, where m is the slope and b is the y-intercept. Okay, let's take a look at our first example. We're asked to use the graph to write a linear function that relates y to x. All right, and when we see our graph here, we see we have points located at -2 and -6, another point at 0 and -3, another point at 2, 0, and another point at 4 and 3. And we notice that those points all lie in a straight path. So we can connect those points with a straight line. Right? We know that this function is going to be a linear function. All right, now when we write a linear function that relates y to x, we're being asked essentially to write the equation of the line in the form of y is equal to mx plus b, where m is the slope, right? M equals the slope, and we know that b is our y-intercept. B is our y-intercept. And the y-intercept is where the line crosses the y-axis. So we need those two things to write the equation of the line. Okay, well, let's start with our slope. To find our slope, we could choose any 2 points on the line. Right, so I'm going to use this point here and this point here. I want to draw a line, a vertical line, to find my change in y. My change in y is 3 units long. And I draw a horizontal line to find my change in x. My change in x is 2 units long. So because this line goes up from left to right, I might know my slope is positive. So in this example, I know my m is going to be equal to 3 over 2. And that is written as positive 3 over 2 because the line goes up from left to right. Your y-intercept is here, where the line crosses the y-axis. And this line crosses the y-axis at -3. So our b, our y-intercept, is -3. So to write the equation of the line, we need our slope, we need our y-intercept. Right? So y is equal to our slope of 3 over 2, right, times x minus 3. Right? So there's our equation of the line in the form of y is equal to mx plus b. Right? So we have written a linear function that relates y to x. We want to be able to do the same thing with the data from a table. Right? In the first example, we looked at the data, the function in the form of a graph. We should be able to write a function from the function information given to us in the form of a table. Now, once again, to write a linear equation, which, in other words, to write a linear function that relates y to x, we need our slope, we need our y-intercept. So in table form, we find our slope by finding our change in y. So our slope here is, or our change in y is a decrease of 2, right? A constant decrease of 2. And we also need our change in x. Our change in x here is an increase of 1, right? And that is constant, right? Notice, -2 over 1, -2 over 1, -2 over 1. So we know that our m, our slope, is the ratio of the change in y to the change in x, which in this case is -2 over 1, right? That's our slope. We also need our b. How do we find our y-intercept from the table? Well, our y-intercept from the table is the output when the input is 0, right? And I am putting a purple box around my output when the input is 0. My x values are my input, my y values are my output. My output when my input is 0 is 3. So our b is going to be equal to 3. So now we have all the information we need to write our equation. We have our slope, and we have our y-intercept. So y is going to be equal to -2 times x plus 3. There's our linear function that relates y to x. It is simply the equation of the line in the form of y is equal to mx plus b. Alright, so on your own, I had my students, right, they worked on these on their own, but let's show these two examples as well. Right, in our first example, we're given the data in the form of a graph. So we need our slope, we need our y-intercept. Right, we could choose any 2 points here, so I will choose these 2 points on the graph. Vertical change of 2, horizontal change of 4. But this line goes down from left to right, and we always have to be careful when the line goes down from left to right. Right, we want to be able to see, right, that the slope is negative. So our m is equal to negative 2 over 4, which simplifies to negative 1/2. Our y-intercept is here, right, and that point is located at negative 1. So our b is negative 1. So for example 1, which asks us to write the linear function that relates y to x from the data on the graph, we have our slope is negative 1/2. We have our y-intercept is negative 1. So our equation would be y is equal to negative 1/2 times x minus 1. Alright, we want to do the same thing using the information from the table. Right, so we need our change in y values, which is 0. Our change in x is an increase of 1. So our m, which is the change in y over the change in x, is going to be 0 over 1, which means we have a slope of 0. Slope of 0 we know is a horizontal line, right? But to write the equation of the horizontal line, we still need that y-intercept, right? Because where will that horizontal line cross the y-axis? Once again, we need our output when the input is 0. So we look at the data in the table and we find our output when the input is 0, and I could see it right here that our b is going to be equal to 2. So once again, we have all the information we need. We have our slope is 0 times x plus 2. 0 times x is 0, so y is equal to 2 is the equation of the line in y is equal to mx plus b form, right? It is the equation that relates y to x. We continue. Okay, here's another example, right? It says you are controlling an unmanned aerial vehicle, UAV for surveillance. The table shows the height y in thousands of feet. The UAV x in minutes after you start its descent from a cruising altitude. Part A asks us to write a linear function that relates y to x, interpret the slope, and interpret the y-intercept. Okay? Well, we need this information here, our change in y. We see a decrease of 5 each time. Our change in x, right, we're seeing an increase of 10 each time. So our m is still going to be equal to the change in y over the change in x, which is going to be negative 5 over 10, which simplifies to negative 1/2. Just as we did in the other examples, we still need our output when our input is 0, right, in order to find our y-intercept of b, or b for short. And here is our output when the input is 0. Our b is equal to 65,000, or 65. They're asking us to interpret the slope and the y-intercept. Well, since we're working on the slope, let's do the slope. The slope, or the height, we'll do the y-intercept. The y-intercept is the height in thousands of feet. And we're told that the y-intercept here is 65. So that 65 represents 65,000 feet. And that 65,000 feet, from the information in the problem, that is our cruising altitude. Alright, that is our cruising altitude. If we're interpreting that slope, right, the change in y over the change in x, we have a decrease of 1,000 feet every 2 minutes, right? So we have a decrease of 1,000 feet every 2 minutes. 2 minutes. All right, so we've interpreted the slope, we've interpreted the y-intercept, but we need to write the equation. So our equation would be y is equal to negative 1/2 times x plus 65. All right, let's continue. Part B here, it says to graph the linear function, which they've done for you already here. We see our equation, y is equal to negative 0.5x, which is the same as negative 1/2 plus 65. Notice the line goes down from left to right because the altitude is constantly decreasing. That's why our line is straight. Find the height of the UAV when you stop the descent after 1 hour. Well, after 1 hour, 1 hour is 60 minutes. And because 1 hour is 60 minutes, we go from 60 minutes, we come up here, right? We see this point here, right? That's in between 30 and 40. So what's the height? That height in between 30 and 40, that's going to be 35,000 feet after 60 minutes. All right? Next problem. I want to be able to compare these two functions here. The earnings y in dollars of a nighttime employee working X hours are represented by the linear equation y is equal to 7.5 times x plus 30. The table shows the earnings of a daytime employee. All right, so here's the daytime employee, right, because that's the table. There's the nighttime employee. Which employee has the higher hourly wage? Well, the daytime employee, let's see what's going on here. All right, and it looks like there is an increase of $12.50 every hour. Right, that's what we see here. An increase of $12.50 for every hour. So the daytime employee, they're making $12.50 each hour. Well, what's the nighttime employee make? Well, the nighttime employee's equation is represented by this equation up here. That's 7.5x plus 30. That's 7.5. That's the hourly rate, 7.5 for each hour. So the nighttime employee only makes $7.50 per hour. All right. Which employee has the higher hourly wage? That's the daytime employee. All right. Next page. We want to write a linear function that relates the daytime employee's earnings to the number of hours worked. In the same coordinate plane, graph the linear function that represents the earnings of the two employees and interpret the graph. Well, that's already done for you here. The nighttime employee is represented by this graph here. The daytime employee is represented by this graph here. If we want to write a linear function that relates the daytime employees to the number of hours worked, let's do that. The daytime employee would be y is equal to $12.50, right, for each hour. So there's the equation for the daytime employee. It says what? Interpret the graphs. Well, what does this point represent here? Well, anytime we graph two equations in the same coordinate plane, right, that represents a system of linear equations. The intersection point of the system of linear equations is the point at which both equations are the same. So it's after 6 hours that the daytime employee and the nighttime employee make the same amount of money. Once you go more than 6 hours, the daytime employee is going to make more, and the nighttime employee is going to make less money, right? And that's what we're seeing with those graphs. Now, we can do that mathematically as well, right? Because we have the daytime employee here, the equation. On the previous page, we were given the nighttime employee's equation. Y is equal to 7.5x plus 30, right? That was the nighttime employee. And we can do this mathematically, right, by setting up a system where we'd have 12.5 times x is equal to 7.5x plus 30, right? We solve that equation, removing the variable with the smaller coefficient. So we want to subtract 7.5x from both sides of that equation, right? We wind up with 5x. It's going to be equal to 30. And when we divide both sides by 5, we wind up with x is equal to 6. Right? And that's what we see on the graph. Right? The 6 hours here, right? If I come down here, right, we have the 6 hours, oops, right? We have the 6 hours, and that's what we see here. 6 hours, they make the same amount of money, right? This would be the break-even point, you know, if we're talking about it as a system, right, where they both make the same. But after 6 hours, the daytime employee would make more than the nighttime employee. Okay? Now, the last problem we did for the lesson is this on your own question. Right? It says Manager A earns $15 per hour and receives a $50 bonus. The graph shows the earning of Manager B. Question A, which manager has a higher hourly wage? Right, and let's delete this. This shouldn't be here. All right, delete that. And after how many hours does Manager B earn more money than Manager A? All right, let's take a look one at a time. Manager A earns $15 an hour plus a $50 bonus. All right, $15 per hour plus the $50 bonus. So let's make a table of values, inputs and outputs, to see what the earnings are over time. So let's do that for 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. Right? Let's do that. So 15 times 1 plus 50, 15 times 2 plus 50, 15 times 3 plus 50, 15 times 4 plus 50, 15 times 5 plus 50. Our outputs, 15 times 1 is 15 plus 50, that's 65. 15 times 2 is 30 plus 50, that's 80. 15 times 3 is 45 plus 50, it's 95. 15 times 4 is 60 plus 50, 110. 15 times 5 is 75 plus 50, that's 125. All right, well, which manager has the higher hourly wage? Well, let's start with Manager A, right? Their equation for A is going to be, where do I want to write that? Problem A, which manager, their equation would be y is equal to 15x plus 50, right? What about Manager B? Well, we have to get that from the table. So we need the change in y over the change in x. Change in y here is 75, change in x is 3. Right? Change in y or change in x, 75 over 3. Right? It's 25. Oops. That's right, 25 this time. Right? That's 25 over 1. Right? So Manager B is making $25 an hour. Right? So we have y is equal to 25x. Manager B makes more money per hour. The higher hourly wage, that's Manager B. Manager B for Part A. Part B asks us, after how many hours does Manager B earn more money than Manager A? Well, if we graph the information from our table, I'll do that in black. We have 1 comma 65. It's going to be 50. 1 comma 65 is going to be about here. Then we have 2 comma 80. 2 comma 80 is going to be here. 3 comma 95, it's going to be here. We have 4 and 110, going to be here. And then we have 5 and 125, right? That's going to be here. If we graph that line, right, it should go through 50, right? We graph that data, we see our $50 bonus, right, for 0 hours for manager A. And we see an intersection point. Oops, wrong pen. Right, let's undo that. Right, we see an intersection point right here. Right there. Right, so for part B, after how many hours does manager B earn more money? It's going to be after 5 hours. After 5 hours. And we see it graphically here, right? If I extend that black line, let's extend that, right? If I extend that black line, right, we see it there, right? The blue line is going to be higher, right? The blue line here is going to be higher than the black line. But we can also do it mathematically, right? We do it mathematically. We'd have 15x plus 50 is equal to 25x, right? We want to solve that equation for x. So we would subtract 15x, right? That's 0. So we'd have 50 is equal to, what's that, 10x. And when we divide both sides by 10, right, we get x is equal to 5 hours, right? So we could see it on the graph and we could see it mathematically, all right? So that's the lesson today. We want to be able to see the functions graphically, be able to write an equation from the graph. We want to be able to write the equation from the function from a table as well. All right. There are the different views of the function. We have the graphic view, we have the table view of the function, we have the word view of the function, and we have the equation view of the function. So we have 4 different views of the functions, and we want to be able to work, between and among those views. All right. I hope that has been helpful, and we'll see you soon.